All right, everyone, I'm back. Part two of the parametric mug. This is our current state of progress. I'm not sure why that's showing me instead of the right window. One sec. Hmm. Hmm. We have to restart the capture. All right, let's go. This is our current state of progress. We've got the cup drawn out. We can make it wider. Change the thickness, the bottom thickness. And then the last thing we were doing was working on the bracket. And this is what the bracket currently looks like. It's pretty badly disfigured. Just looks like these two sheets for some reason. We did a bunch of math. Well, a little bit of math, honestly. It wasn't that bad, but trying to figure out the coordinates of the various points on the polygon that define the perimeter of the bracket. That that might be correct. There's no way to really tell yet because it's just not drawing correctly. And when we go into VS Code, this is our bracket outline path that we were working on. And if we just kind of simplify away all of the more complicated portions of the math and just try and draw a rectangle, basically we're starting at the extension length 0. We're going to the extension length and half length, and then going mirroring that, and then eventually coming back to the extension length 0. This should basically draw. These are these are the same points. These are actually only 3 points. Let's go back into sketch and think about what's happening when we do that. We're drawing the extension length half width, which is this point right here. Oh no, we're drawing the extension length 0, the extension length half width, and then we're coming right back down here. So that does make sense that wouldn't draw anything actually. We should come here. We should go back to so we should go extension length 0, extension length and half end width 0, comma end width over half end width. Okay. So extension length 0, extension length half end width, and let's go to, just for debugging, let's go to new babylon dot vector 3. Let's go to 0 on the x coordinate. Again, we're on the xz plane here. And on the y coordinate, we want to go to the half width and half length. And then we can go to 0, negative and half length. Extension length, negative half end length, and then back to the point that we started at. So this should draw like a rectangle. I don't know why the auto format isn't working on this file, but it's okay. So right now this should draw like a half rectangle if our actual general drawing, situation is correct. But it looks like it's definitely not because we're still just getting these 2 bars. I have to go back and look at that Babylon code example. So we're creating the profile in the XY plane. I don't think that has to be in the XY plane. Maybe it does. Maybe that's the issue. It might be like this extrude might be wanting it to be in the XY plane. So we can do that and then just reorient it. Let's see if that helps and makes things work. So this is the same. Basically, you just have to move all of these y coordinates to the z coordinate. This is a very strict no AI code challenge, by the way, if you didn't pick that up in the previous installment. Okay, wait, it looks like something is coming out that looks a little bit better. Yes. Oh, and there's no end caps, so that's probably also why it was kind of hard to see what was happening. Caps? Yeah, cap. Double true. Is this just a Boolean? Let's see if we can get like a code hint here. Cap, a number. Okay, so it's probably an enum. Is it is it gonna be on the mesh class? Cap all. Yes, yes, it is in the mesh class. Okay, let's go back. We should probably fix the camera too to like be more like this. But anyways, that does look right. That's a rectangle. So let's bring this back. So the issue was that we were using the XZ plane because that's where we want the final thing to be, but this mesh extrusion or this polygon extrusion function wants us in the XY plane. So we might have to rotate some things around to get them to work once we actually have the bracket drawn out. Or maybe not, maybe it's like it just wants it in the XY plane, but it actually draws it in the XZ plane. I don't know. So this is the first point, second point, right. Let's go back to sketch just to make sure because we added those weird points and I want to make sure we're deleting the right points. So we're starting at extension comma 0, extension end width, extension y plus, or extension y1, and then this x is going to be like negative. We're going to subtract the diameter, right, minus cup diameter. I'm not sure why this point is showing up twice. It shouldn't be here twice. So we'll just delete that, and then once we have that point, oh right, because one of them is going to be negative, right? No, this one's already positive. This one's negative at the bottom. And then once we're down here, we go back to the offset. We go back to the tangent cutoff. Right, yeah, we go back to the tangent cutoff y1, but negative y1. Okay, so I do know why that point was there. This point should have been there, but it shouldn't have been with this. It shouldn't have had the minus cup diameter. And then these x0 points shouldn't be there because it'll go to the offset and then back to this extension comma negative end width and then back to the start point. I think this is right. We can split this up into 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we can split this up into 2 sets of 4. Okay, let's go look at the results. See what it looks like. It's looking a little bit. It's looking a little bit incorrect. I mean, what? Oh, because this is 90. I think the bracket draft angle. No, the bracket draft angle was 100. And then obviously it's not reactive yet, so there's nothing actually happening when we change the value. Let's see. Right, the y1 is coming into play up here. Oh, I see what's happening. Wait, did we convert this to, yeah, we did convert this to radians. I'm just gonna do something really dumb and make sure that our radians conversion is actually correct. Um, let's do degrees to radians formula. You can never be too sure. Degrees times pi over 180. Is that what we're doing? Is that actually what we're doing? I hope so. Well, we're doing degrees divided by 180 times pi, but that's the same thing. We'll change it up though just to make it look a little bit nicer. Okay. Let's go into our double view so you guys can see the results. Again, not looking good. First of all, it's not symmetric to the cup, which is weird. Well, yeah, it's not symmetric to the cup. It is in the XZ plane. Let's see. By the way, this is gonna have to be a short session because I only have about another hour to work on this. So let's look at this situation with the bracket extrude path. We can look at that example, and it looks like the path is in the YZ plane. So let's make sure that we're following that as well in our code. We kind of are. Let me just see. Let me just swap this and see if that does anything that looks more correct. Okay, no, not really. I mean, it's still just a rectangle. It almost seems like it will extrude it along the path in the same manner regardless. Like the path will define the orientation of the final extruded shape. So it's like it wants the path in the XY plane, or it wants the outline in the XY plane, but then you can orient it depending on the actual extrude path, which is an interesting way of doing it. Makes a lot of sense, actually. But let's put that back in the Y direction so that we get it in the orientation that we want. And then, why isn't it centered to the cup? That's another thing that we should think about. Are we moving it is my question as well. Create mug. Yeah, we are. We're moving the bottom bracket. Let's see what happens when we don't do that. I think it'll probably just end up right in the middle of the mug. Yeah. Ends up in the middle of the mug and it's still not properly centered. So this was correct. We do want to move it in the positive X direction. And it should be where we put it, I think, right there. So it looks like our points are just not correct, and we're just getting a rectangle. But that's weird because we're defining 7 points because this point is the closed point. Let's look at how many points are actually in the sketch shape to make sure that we're kind of on the right track with that. 1, 2, 3, 4, 5, 6, 7. Yeah, there are 7 points. So that's correct. The number of points is correct. Let's methodically go through and make sure that we're on the right track. So, I think I had a, yeah, okay, this is good. Can you guys see that? Yeah, you can. Okay, so yeah, I've got this pulled up to the side here. And let's just look at it and make sure that we're defining the right points on our outline path. So we've got extension comma 0, that's right, we're starting here. Does that make sense though? Yes, it does. And then we're going up to this point, which is extension plus half the end width. That's correct. And then we're going to the tangent cutoff, which is here for the x. What is our tangent cutoff as a parameter? 0. Okay, I think that should be okay, because that means we're just going to end up coming back here. So we're going to the tangent cutoff. And then in our y coordinate, we're going, okay, they shouldn't just be y1. That's an issue, I think. It should be y1. Well, what is y1 actually? Y1 equals, yeah, y1 is just, no, y1 does include the end half length. Which is okay, I guess. It's y1 is a little bit different in our code than what it is in this little drawing here, but that's what it should be. It should be the end width over 2, which is this, plus this, which is tangent of the draft minus 90. So yeah, the end half length plus math.tan times extension length. Wait, this is extension length minus extension length. This is times 0. So that's why, that's a bug right there. It should be extension minus the cutoff, right? Because we want the opposite. It's tan theta is opposite over adjacent. So if you want the opposite, we want tan theta times the adjacent. And this adjacent length is the extension length minus the offset. So this should be params dot not handle offset distance params dot tangent cutoff. Now let's see what happens. That's looking a little bit better just because it's at least has like a kink to it. It looks like the orientation is incorrect. It's off by 90 degrees. So we need to rotate it along the y-axis by 90. Let's just think about for a second why that's happening to see if we could redefine these coordinates instead of having to rotate it. We're defining well, we're defining it on the XY plane, but we're extruding it on the Z plane. So I think it's because Babylon uses a right-hand coordinate that maybe right-hand coordinate system that when it extrudes it on that, or sorry, and extrudes it on that Y path, not the Z plane, but it extrudes it along Y. The Z direction ends up being opposite to the Y or flipped like 90 degrees compared to the XZ plane. I'm not entirely sure, but again, we're on a time crunch here and we know what we have to do to make it work. So I think the move is going to be to simply rotate the extruded bracket. The question is, do we do that in draw bracket or do we do that in create mug? I think the fact that we're kind of positioning things in create mug to get them to the right place, we should probably just rotate it here as well. We'll leave a comment though. The computed shape is rotated by pi over 2 along its y-axis. So we correct for that here. Bracket bottom dot rotates the mesh around the axis vector. Yeah. So the axis vector, I think we can do Babylon dot vector 3. I think there's like constructors, like y or up, right? I think up is like, yeah, 0, 1, 0. And then we want to pass it the amount. Is this degrees? I don't know. Let's assume that it's radians and see what happens. Looks like it was indeed radians, but we want to rotate it the other way. So we'll do negative. Yes, yes, this is looking good now. Okay, we need to fix the camera because that's really annoying. But that's looking kind of like how we want it. I'm really happy about that. I'm really happy about that. We need to fix the camera and the lighting, but I think we should do that at the end because we have some good momentum going with this bracket situation. Okay, we're actually gonna have to rotate both brackets, so maybe we should just rotate it in the actual bracket draw function itself, honestly. Then that should still work, right? The same way. No, oh yeah, it does. Okay, good, good, good. Okay, good. And then let's draw two brackets now. Bracket bottom const bracket top equals same thing. Draw bracket, same params, right? Yeah. Bracket params, cut params dot outer diameter. We still need to do that cut thing to cut away the point where the bracket intersects with the cup. But can we add multiple? No, we can't. Can this be a mesh or can this be an array? No. It's okay. We'll just call this function twice. Bracket top. And then bracket bottom dot position dot x. Bracket bottom dot position dot y. We want to move this bracket up by the bracket offset amount. So cut params dot or sorry, not cut params, but we need more parameters. We need the actual assembly params. I guess we call it mug parameters. No, it should be called assembly parameters just to match the variable names. Mug assembly parameter. and then in create mug, const mug, we'll call it assembly params. I went rock climbing today and my hands haven't recovered, so that's why I'm typing a little bit weird. Okay, what are the mug assembly parameters? The bottom bracket offset, the bracket gap, and the handle bottom bracket offset. Bottom bracket offset, millimeters to meters. Bottom bracket offset input millimeters dot value. And then it was the bracket gap, right? Why is it not complete? Oh, that's why. Bracket gap, millimeters to meters. Bracket gap input millimeters, nice. And then finally it was the offset between the handle, right? The handle, yeah, the handle bottom bracket offset. Handle, bracket handle offset input millimeters. There we go. And what's this? Oh, we want the value. Okay, good, 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 good. Bracket params, assembly params, go to the create mug function. Position.y is the assembly params dot bottom bracket offset. I believe we do need to look at exactly where the origin of the extruded mesh is. I do think it should be at the bottom. I do think it should be at the bottom, but we'll add, let's go into like this bracket and we'll just say extruded bracket dot add child, and we'll do one of those helper meshes. Axis helper, I think it was called. Or axis viewer. Yeah, axis viewer. New, I think we can say new babylon.axis viewer and pass it like, what is this? What was the, how are we running this? You have to pass it the scene and then it wants the scale after that. Okay. And is it a constructor like that, or yeah, it is. Okay. Scene, and then we want to pass it like a really small value, like maybe like 5. I think that will make it like 5 centimeters tall. Wait, it doesn't like this. Oh, it's not a transform node. What is it? Oh, because extruded bracket. Hmm. I'm not sure what the axis viewer is and why we can't add it to it as a child. To the mesh. I'm gonna go into the documentation. I think it's worth it just because I think the axis viewer could be really helpful for Or is there a debug? No, okay. Hmm. What is this? It says it's the hierarchy, the bone axis viewer. We would have to probably get into the actual like code itself just to see. Okay, so this returns, okay, so it's like a set of transform modes. So we could probably just say um probably only need like one of the axes, so we could just say x-axis so that we can get a sense for what the x-axis is. Well, we already know what the y-axis is because we rotated it around that. So yeah, it looks like the axes are in fact aligned the way that we would expect them to be. So I'm not sure what's going on with that. Oh, right. We wanted to see where it was within the mesh, and it looks like the mesh's 0 point is, well, this mesh hasn't been translated at all, and we can see that it's sitting at the bottom in the middle of it. So it looks like the mesh's origin is at the bottom face of the bracket. So that's good. That will make it very easy to apply the correct offset, which we've already done. And then the bracket top is going to be same y, or sorry, same x position as the bottom bracket, but this time the y position is going to be the assembly params. It's going to be the bottom bracket offset plus the bracket width, or sorry, the bracket thickness, plus the bracket gap. That's an assembly param. That's good. That's good. That looks excellent. I think we have the brackets down. The only part is that we need to cut away the excess, and then we also eventually need to make the values all reactive. But looks like we've got the brackets down and ready to go. So let's do the thing that cuts them away, because we can't just leave them like half done. Um, Draw bracket. When we draw the bracket, we create the extruded bracket and we rotate it, and then let's just say now we cut away the cup. So let's create a mesh that is like similar to the cup and maybe just a little bit thicker than the bracket. So const cup subtractor equals, did I spell that wrong? No, I guess it just doesn't think that subtractor is a word. Is it subtractor with an ER or with an OR? I want to leave it with an OR. Just sounds better. We're gonna do babylon.create.meshbuilder.create cylinder, and this cylinder is going to have what are the, I totally forgot what the arguments are for this. Create cylinder. Oh, right, it wants the name and then the options. So this will be the bracket cup subtractor, but it's also a temporary. And then we want the diameter to be the cup diameter, the cup outer diameter. We want the height to be a little bit higher than the bracket. So let's add a variable called subtractor padding. Oops. Const subtractor padding equals, let's just say it should be like it should be, well, if we're going to set it to half the bracket width, then we don't even need. It should just be the bracket height. Params.thickness times 2. We'll just make it like twice the thickness. And then we will move the cup subtractor down by half of the thickness so that it's evenly, so that extra padding is evenly distributed. So cup subtractor, oh oops, we're still inside this. Cup subtractor dot position dot y equals negative params dot thickness divided by 2, and then we'll create the CSG objects. So extruded bracket CSG, that's a new variable, equals CSG2 dot from mesh extruded bracket, and then the cup subtractor CSG equals babylon.csg2 dot from mesh cup subtractor, and then we'll go ahead and subtract the CSG from the cup subtractor from the extruded bracket. So we'll do extruded bracket CSG dot subtract cup subtractor CSG, and then we'll make a new mesh. So const finished bracket equals extruded bracket CSG dot to mesh. And then we'll name this bracket finished, but also we're going to probably want to rename it once we get it back. Let's see if that actually works and make sure that we're returning the correct bracket, or the correct mesh. And then let's see where we're calling bracket here. We could give this a name function, or we could just rename it. Bracket bottom dot name equals bracket bottom bracket top dot name equals bracket top. Cool. Let's see what we're working with now. Are things looking generally correct? No, they are not. What's going on? Why? Oh, well, we do have to remove the meshes that we created. So we'd have to get rid of those temporary meshes. So once we run the subtract thing, create the finished bracket, let's dispose of the extruded bracket. And let's dispose of the cup subtractor. Now let's see what we're working with here. We still have this whole intersection. Looks like the CSG just like didn't do anything at all, really. Um, let's try and figure out what's going on. We are passing it we are returning the finished bracket, which is correct. The finished bracket is the extruded bracket CSG, yeah, dot subtract. That's Oh, this is returning a new CSG. Let's look at Okay. Okay, I see. I see. So it's not going to modify. It's going to return a new is it going to return the same CSG object, or I actually don't know. But basically this like this finished bracket, it might not be when we run extruded bracket dot subtract, it might not be actually modifying the extruded bracket CSG object. It might be returning a new CSG object, which is the result of that subtraction. So we'll just kind of simplify that whole situation by doing that inline, and then we don't really have to deal with whether or not, that's the case with the modification in place. It looks like that didn't fix the situation. That's interesting. So we're still dealing with a situation where, interesting, interesting. It actually does look like there was a cut made um, in the wrong place. So that's also good to see. But that makes sense because we didn't offset these forward. We didn't offset those forward, and they're too far down. Why? Why is that the case? Let's look at the cup subtractor position. We did the params dot thickness divided by 2. We made the height twice the thickness. So what would happen if we just didn't move it down? Then it would slice it right at the top. Let's think about this a little bit more carefully. We made it twice. Yeah, so it looks like it's like right, probably flush with the top, creating like a planar surface when we don't subtract it. So it looks like we probably want to add it. But why is that the case? Um, I would think that we would want to move it down because be they would both be on the same plane already, and the subtractor would just be taller than the bracket, so we'd want to move it down to get it towards the middle. But if we just make this positive and we move it up instead of down, what would happen then? Then it works the way that we expect it to, at least in terms of the cutting action. Um, we move it up. It could just be a difference between the way that the bracket is being extruded and the way that the cylinder is being drawn. I'm not sure. But we're at a point in time with this project where if it works, it works, and we just have to move on without understanding it, which I don't love, but sometimes that's just the case. So we also need to make sure that the cup subtractor is in the correct location. It looks like we have to move it backwards by the extension, I think. Equals negative params dot extension length. Let's double check when we're creating the mug. We're setting the x to the, yeah, right, not the extension length, but the outer diameter divided by 2. So this is not right. This should be the cup outer diameter divided by 2. And then that looks like it's almost correct, but not quite. Also, the mesh is being left open. So let's think about what's going on there. I think one thing that we should do is not dispose of these meshes, that we can just see them and see how they work. Right, so that's okay, maybe it is time to fix the camera situation. But that looks about right for the bracket. Removing the cup subtractor back by half of the diameter, which is also correct because we want it to be tangential. We want the end to be tangential to the origin of the bracket. So this should be right. Might need to look at this. We need to look at how we're moving the bracket and if it's not moving forward enough. Yeah, it looks like the brackets just aren't moving forward enough at this step, in the create mug step. Cup rams dot outer diameter divided by 2. Huh, interesting. It's interesting that temporary CSG shape completely blew up. Yeah, so as you can see, when we move the outer diameter, it's not quite like the origin of the bracket has shifted because after the CSG operation, the origin is no longer where we wanted it to be, right where it was originally. So that's interesting. The CSG operation seems to have shifted the origin of the bracket. We can probably verify that by adding the axes viewer to it. Let's add an axes viewer. Let's add an axes viewer and then add that to the finished bracket. Now let's see what happens. Yeah, so as you can see, the bracket origin is now like here instead of being right where we cut it, which is where we kind of wanted it to be and where it originally was. Because if we also add the axes viewer to the extruded bracket, Yeah, see, if you add the axis viewer to the extruded bracket, you can see that it is right here in the middle where the cutout occurs. The big axis viewer is overlapping it, but you can see these little arrowheads um, which have their origin at the same place. So after the CSG operation, the origin of the bracket is actually changing. And that is difficult because I don't know if there's a clear way of knowing where that origin is relative to where it once was. I might need to come up with a way of either preserving the original origin or reestablishing the origin and knowing where it is relative to where it used to be. Oh, okay. Let's think here. Part of me thinks that a solution could be just to wrap everything in a container, and then the origin of the container shouldn't change it based on this CSG operations, but it could if the container changes size to fit the new mesh, which is going to be smaller. Another solution would be to just use a different origin altogether that isn't affected by the CSG operation. Um, should we just go on DuckDuckGo and maybe search something like babylonjs preserve origin after CSG? No, I'm not seeing anything. Yeah, it looks like this forum might be hinting at a possible solution. Secondly, using CSG will set a local origin in an unknown place and certainly not at the center of the triangle, the actual center of the triangle, while finding the intersection of the median again difficult. Right. Box will not set pivot point. Right, so I guess like they're using the bounding box. Um, I think we could maybe get the bounding box, get the center, get the old origin, and then since the CSG will occur in the same place, save that point, and then set that old point as the new origin. Let's see if we can do something like that. So we want to get the world coordinates of the old origin. So extruded bracket get the world coordinates of the origin of the unmodified extruded bracket. Const extruded bracket pre-subtract world equals extruded bracket dot, well, it'll just be 0, so we can just do get the world matrix. Or maybe we could just get the world position. Is that, no, we can just use the world matrix. Okay. And then after the whole extrusion occurs, we can say finished bracket dot set pivot matrix. Then we can set that to the extruded bracket pre-subtract world. Let's see if that works. This is getting really jittery. No, that did not work. That did, in fact, not work. It also looks like we can't add the axes viewer as a child to multiple meshes. Yeah, it's still putting the pivot point like in a new position. Hmm. Maybe we have to pass false to that translate function if it's trying to translate it back. No, that just totally mangled the whole thing. Yeah, no, that just mangled the whole thing. Are we doing it after rotating it? Yeah, we're getting the world coordinate. We're getting the world. I think what we should do is like project the position to the world, into world space. I think what we can, the way that we would do that is to do extruded bracket dot position, and then I think there's a Babylon dot transform world. No, Babylon dot matrix dot. Let's just look this up because it's not worth figuring it out. Oh no, this is Google. It's giving us an AI suggestion. That's unacceptable. Oh no, no, this is just babylonjs get world position of mesh. No, why is it giving us these AI suggestions? Hmm. I think we might have to look at the matrix API. Dot transform coordinates. Wait, this is gonna default to Google. Oh, it's on vector 3. Okay, think I think I know what we have to do now. Um, I think I know what we have to do now. World matrix. These variable names are insanely long. Extruded bracket dot get world matrix true. Recompute it. Why is it expecting 0 arguments? Oh, compute world matrix, not get world matrix. Const extruded bracket pre-subtract pause equals babylon.vector3.transform coordinates. This is where we want the position, so extruded bracket dot position, which should really be 0, like it should be at the origin. That's what I don't get actually, because this is gonna be at the origin, so the world position is just gonna be at the origin as well. I think we just have to set the pivot after the extrusion happens. After the cut happens, its position is going to change because its origin will be different. Right? Like if we do console.log finish bracket dot position, this will no longer be 0, 0, 0, I think. Let's see. You guys can't see the console, but I'll let you know what it says. Oh, it is 0, 0, 0. I would have thought that it would no longer be at the origin. Oh, well, we're not moving. Yeah, we're moving the cutter, or we're moving the subtractor back. Let's just get rid of these 2 calls that actually draw the brackets and move them. Or that we'll keep 1 call that draws the bracket, but then we'll just suppress everything else so that we can see just the bracket and get a feel for what's going on just with that. Right, so this is our bracket. We've drawn 1 bracket. We can see the other one, its origin is not the same because it's not in the same place, even though we haven't actually moved it at all. It looks like its origin actually not only moves from where it used to be in the X direction, but it transforms in the Y direction too, so it's in the middle now as well, which is weird. So the whole CSG process will actually shift the origin of the final constructed geometry mesh. Let's see if there's something. What is ignore world matrix? Is that what happens if we ignore the world matrix? I don't think that will result in what we want, because we do need to rotate the bracket in order to correctly apply the cutout to it. But let's try that. Let's try that just to see like what happens to the origin when we do that. It won't be cut in the right place. But it looks like at least the origin at least remain the same? No, it didn't because it's shifted down. Just playing with some different values now. Yeah, it looks like yeah, no, that's not right. Okay. Okay. This is gonna require a little bit of thinking instead of just mashing at different, just trying different things. When we draw the mesh, we run the CSG. I wonder what happens if we run the CSG in a container. Will it reposition the resulting object relative to that container? And if not, can we just use the position of the container to move the final? Well, no, that doesn't really make sense because we're creating CSG objects from each of the individual meshes, which is probably going to make the CSG object agnostic to the hierarchy that the mesh used to create it belongs to. Maybe we should have looked a little bit more closely at that forum answer on Safari. No, they're just using a bounding box. One of the cool things about Babylon is that these ancient playgrounds will still work. I mean, this playground is almost 10 years old. But yeah, that's not the move. That's not what we want. Let's go back into VS Code. Another thing I could think of is that we could position the bracket how we want it and then cut away the circle. I really, really don't like how it's moving the origin after it runs the CSG operation. Because it's like, where is that origin moving to? Like it seems arbitrary. Like it looks like, I mean, it's not completely arbitrary, I guess, because it looks like it's moving. It looks like it's moving it to the center of the bounding box. But in this case, that's really bad for us because I think the most promising solution is to find the world's to get the world coordinate of yeah, to get the world coordinate starts at 0, 0. We move the cup back. I just don't get why when we ran this finish bracket dot position dot toString, why this was 0, 0. Because its origin is moving, so it should no longer be at 0, 0. Oh, well maybe if we transform that to get the actual world position of it. So const finish bracket world pos equals babylon.vector3.transform coordinates. We'll give it the finish bracket position. Because that might be like the local position. And the transformation would be the world matrix. So it would be finish bracket dot compute world matrix true. Oops, this shouldn't be toString. And then we want finish bracket world pos. And that should not be 0 because we know that the origin is moving from where the bracket used to be. Oh, well, the world pos is 0 because right, because it's actually shifting the whole thing back. It's not only moving when it creates the CSG and you do two mesh, it not only moves the origin, but it moves the whole mesh so that its origin is at the old origin, which makes it so that we can't actually compare them after it's done. Let's see, maybe there might be another way to think about this. Or maybe there's another two mesh options. Two mesh scene, and then what are the options that we have here? Oh, center mesh. True to center the mesh on 0, 0. Maybe if we make this false. Yes, that's what we wanted, I think. There's some really bad Z fighting going on, but if we dispose of the old meshes, sorry, now you guys can't, now you guys should be able to see this, but if we dispose of the old meshes, I think, yes, that's what we wanted. So center mesh. So maybe if we run center mesh, we don't even need to do the whole comparison thing to repair the location of the origin. Wow, okay, yeah, that was it. It was just the center mesh option that was killing the whole thing. So now we didn't actually have to do all of that comparison to find the transformation that it went through with the new origin. The origin will just remain the same if we give the center mesh argument or option as false. So now we have the brackets drawn. Nice. Now we just have to draw the handle. Draw bracket, draw handle. This should probably be the easiest one because it's just a cylinder. So, oh, we also have to make a cutout for the handle in the bracket. I'm kind of wondering, like, if we really should, though. For now, we won't, and we'll just let them intersect. But maybe at some point, that could be the move. I'm not sure yet, actually. Yeah, for now, we'll just let them intersect because it's not like they're going to interfere the way that the bracket would have filled the negative space inside the cup. So we have to cut it away. We don't have to make a hole in the bracket for the handle. Okay, so for the handle, we can just create a cylinder. So babylon.meshbuilder.create cylinder. We'll call this handle. Give it some options. Diameter. Params.diameter. Height. Params.length. Okay, that's okay. And that's it. We can just return that. Easy. Easiest function yet. And then we have to pass the handle params, bracket params, const handle params. Luckily, there's only two of these, the diameter. So millimeters to meters, handle diameter input. Whoa. Handle diameter input millimeters, dot value. And then the length is millimeters to meters. Handle length input millimeters dot value. And then we'll just pass those parameters as the third argument here. Update the function definition to take that as the third argument, and then we'll do const handle equals draw handle params, and then we'll add the handle to the mug parent. Mug parent dot add child handle. And then now to position the handle, because if we just run this now, we'll see that the handle will be like right in the middle of the mug. Yeah, well, it's not even in the middle of the mug. It's in the middle, but like also positioned downward. So we need to position it first. Yeah, first we'll move it in the X direction by, well, if we move the handle in the X direction by just the diameter of the cup, so cup params dot outer diameter, just to show what happens with that, it'll be in the middle. Outer diameter divided by 2. We want to move it by the radius. That'll be one like component of that transformation, and that will move it so it's tangential, so it's right on the tangent edge, right, of the cup. And then I think when we defined the handle, the assembly handled offset, we said that was from the tangent edge of the cup, the outer edge of the cup to. We can check Fusion again to see like what our sketch looked like. I'm pretty sure, yeah, we said that was from the outer edge. It's this value from the outer edge to the middle. So we just have to move it once we have it at that outer edge, which we already have it at by translating it by half the diameter, we just have to translate it again by that offset. So let's go back to Fusion, and then we'll do plus assembly params dot. Was that not an assembly parameter? Was that a bracket parameter? I don't like that. I don't like that. That should have been an assembly parameter, right? The handle offset distance. I mean, I guess it's technically like the bracket holds the handle, but okay. Okay, I think either one is like kind of makes sense, so we'll just leave it the way it is. But that's kind of worth thinking about, right? Okay, and now we have like the handle in the right X position, and then to move it in the Y position, if we just move it up by half of the handle height, it'll be like flush with the bottom of the cup. So let's do that. Handle dot position dot Y equals handle params dot length divided by 2. We move it by half of its length up. Yeah, so now we can see that it's just flush with the bottom. And then to get it, if we move it up by the bracket offset, then it'll be flush with the bottom of the bottom bracket. So assembly params, oops, assembly params dot bottom bracket offset. If we move it up by that, it should now be flush with the bottom of the bottom bracket. Yes, it looks like it is. It's kind of hard to tell. Let me just hide the bottom bracket. Bracket bottom. Bracket bottom dot is visible, I guess. Is that? Yeah. I think we can set that to false and it should disappear. Wait, but then we won't actually know if it's flush with it. But we can look at the axes helper and see that it does indeed appear to be flush with it. I don't think you can set, I think the opacity is material based, so we can't set like the opacity. We could shift it over to like to the side. We could shift it over to the Z. Dot. No, I mean, yeah, that's kind of no. We'll just shift it over by the diameter, by half the diameter. So this is just to show, this is just to kind of get a sense for whether or not it is indeed flush with the bottom. And yes, like it totally is, right? I mean, we're not using a perfect orthographic projection to really like verify that they're flush, but I'm convinced, and the math is saying that it should be that way anyways. Okay, so it's flush with the bottom, and then we just subtract we want to move it back down so that it's so that there's a handle bottom bracket offset, that distance between the top and bottom, the top of the bottom of the handle and the bottom of the bottom bracket. But when we move it back down, it's too far. What is the offset though? 30. No, bottom bracket offset 20. Yeah, that's too much. No, the bottom. Oh, why is this working? Why is this reactive? It's funny. Okay. Assembly params dot handle bottom bracket offset. That should be right. Because you want to move it back down by the bottom bracket offset. The handle, and we set that default value to oh, am I not giving it the right value when plugging it in? Yeah, I wasn't giving it the right value. The handle bottom bracket offset is the bottom bracket handle offset. So now it has the right value. It's getting a value from the correct ref. And that's it. That's our mug, y'all. That looks good. There's just a little bit more work we have to do to make it parametric, and like if we shift this, right, we want to make sure that the slider is gonna like stop here and say, hey, you can't just like do that. But yeah, I'll show you a full screen view of the result. So yeah, this value is reactive for some reason. I don't know why. I don't remember making it, plugging in the reactivity to that, but it's cool. The cup height is, reactive, and again, like it's tricky because there's all these circular dependencies. Like if we want to make the cut height reactive but guarded, then it won't be able to move past this. So then it'll be like if the user does want to make the cup shorter, they're going to have to reduce the bracket gap first, and then they can lower the cup height, which is like a little bit annoying as like a user. Like if I just want to lower the cup height, I want to be able to slam it down and be like, okay, now I need to change the bracket, the bracket gap. So it's kind of hard to say like what the right way to design the interface should be. And also like this is kind of cool. Like that's kind of a cool mug. And um if you wanted to toggle off the top bracket or something, that could easily be a feature as well. I really like that. Actually, I'm not gonna lie. It seems like, I mean, for me, it would kind of be like an impractical mug to like have to drink it that way, but it's more of like a ladle, but it still looks kind of cool. Let's see if the draft angle is reactive as well. It is. That's so cool. So yeah, it looks like the draft angle thing is working. Like when we raise the draft, we need to fix the lighting and material for sure because it's really hard to see everything. When we raise the draft angle, we can see that like we get this widening of the bracket. And then we can change the bracket thickness, yes. Oh, the reactive because we're using V models. That's why. We change the tangent cutoff, yes, we can see that like it's moving forward and backwards. If we change the cutoff enough and then we make the draft angle small enough, we should be getting no flat facet, but we're not. So there's definitely something going on there. The tangent cutoff is 0. Oh, it's because the bracket tangent cutoff is 0, and then we lower the draft angle. Yeah, then we don't get any facet anymore, which is what we wanted. Let me just make the cup taller so it makes sense. See, now we're not getting that facet, which is exactly what we wanted with the design. We wanted it to be so that you could model in that facet if you wanted to, but also get rid of it too. So that's cool. It looks like this is like 90%. working. There's just some stuff we have to do with the constraints. I don't know if I should leave that to part 3. It's already 5:40. This stream has been going on for let's see. This stream has been going on for an hour and a half. I think that's plenty of time. And I think we should probably leave this to a part 3. But this is cool. Maybe in the part 3, maybe if we do a part 3, it'll also allow us to do a little bit more with it. We'll do some things like fixing the camera, or maybe I'll do that off stream, just because that will pretty much just involve me looking at the Babylon documentation. But yeah, we have this negative cutoff. The handle offset looks properly constrained to the bracket extension. The bracket extension isn't working, which is interesting. That's something we'll have to look into in part 3. This is working though, in terms of like constraints. Well, these constraints aren't updating actually because there's no watchers on the various refs to update the dependent constraints when they change. But yeah, I think that's a good stopping point for part 2, guys. In part 3, we'll add the watchers so that the dependent constraints will update depending on any other constraint that changes. We'll tackle the circular constraint question and figure out, does it make sense to limit circular constraints? How should we treat circular constraints? Maybe we'll try it one way and then see if it totally kills the user experience and makes it difficult to use. We'll clean up the camera for sure. We'll clean up the lighting and materials. Maybe make a drop down where people can select various materials as well. But for now, I think this is a good spot to stop. I'll see all of you in part 3.